Hello everyone. In this session of CCNA series, I will discuss site-to-site VPNs and remote access VPNs. Imagine a company with two geographically separated sites where HQ is located in Abu Dhabi and branch office is located in Dubai. You are expecting to share the resources between the two sites where you have some application servers hosted in Abu Dhabi HQ and needs to be accessed by employees in branch office, that is in Dubai. So here you have two options available, each with its own advantages and trade-offs. First is private WAN and the second one is internet VPN. Let's have a look at those two. A private WAN or wide area network is a network that connects multiple geographically dispersed locations, such as branch offices to HQ, using dedicated lease line or other private network connections. These connections are typically provided by telecom carriers and are used exclusively by the organization. But challenges there are some challenges with private WAN, such as high cost. Lease lines and MPLS services can be expensive due to the dedicated nature of the connection. Another challenge is scalability. Expanding a private WAN requires significant investment in new lines and infrastructure. Then we have flexibility, which is another challenge because adding new locations or users quickly can be very challenging and very costly. For that, we have another solution, that is VPN, which stands for Virtual Private Network. A VPN is a technology that allows you to create a secure connection over a less secure network, such as the internet. Its job is to ensure safe delivery of your data across public network, that is internet. It provides benefit of a private WAN, but over the public internet, significantly reducing the cost while maintaining security and performance. It is often described as tunnel. It is safe from the attackers as your data is encrypted before it passes through the public internet. There are two main types of VPN, site to site VPN and remote access VPN. Let's go ahead and look at those two. A site to site VPN connects again two or more sites together. It provides VPN services for the devices at two sites with single VPN tunnel. For example, if the branch site has numerous devices that require communication with servers hosted in HQ, each branch device does not need to actively establish a VPN. Instead, the network engineer will configure two endpoints using a router or a firewall on each site to create one VPN tunnel. This tunnel will be up and operating all the time so that when any device or at either side decides to send the data, VPN is available. It is ideal in situation when you have multiple remote sites. So these VPN rely on tunneling protocols to securely transmit data between two or more sites. So two tunneling protocols used in site-to-site VPNs are IPsec and GRE. So let's see what IPsec and GRE are. IPsec stands for Internet Protocol Security. It is a suite of protocol designed to secure IP communication by authenticating and encrypting each IP packet. So it defines how two devices, both of which connect to the internet, can achieve the main goals of VPN, that is confidentiality, authenticity, integrity, and anti-replay. It is widely used for site-to-site VPN due to its strong security features. IPsec encryption uses pair of encryption algorithms, which are essentially math formulas to meet a couple of requirements. One, to hide or encrypt the data. Second one, another to recreate or decrypt the original data based on encrypted data. Let's have a look at the process of encrypting data for an IPsec VPN works generally. The four highlighted steps in the figure I'll show you. The first one is the sending VPN device feeds the original packet and the session key into encryption formula, calculating the encrypted data. This encryption key you can call as a session key, shared key, or shared session key. It's up to you. The sending device encapsulates the encrypted data into packet, which includes the new IP header and the VPN header. The sending device then sends the new packet to the destination VPN device. The receiving VPN device runs the corresponding decryption formula using the encrypted data and the session key. The same key value was used on the sending VPN device to decrypt the data, and this is how the original packet is received on the receiving host. The next one is GRE, which stands for Generic Routing Encapsulation. It is a simple tunneling protocol that encapsulates wide variety of network layer protocols such as IP, IPv6, AppleTalk, IPX inside virtual point-to-point connections. GRE itself does not provide encryption, but it is often combined with IPsec for secure transmission. Without IPsec, each GRE tunnel could be used to forward unencrypted traffic over the internet. So IPsec adds security features to the data that flows over the tunnel. A site-to-site VPN exists to support multiple devices at each site and is typically created by devices supported by the IT staff. Which takes us to the next type, that is remote access VPNs. A site-to-site VPN is established to assist various devices at HQ or branch and is commonly set up by devices managed by the IT team, as I said. But you may also, since Corona, this has become common, you may also have employees that work from home, coffee shops, or anywhere else in the world. These users will require access to the corporate network. But a site-to-site VPN won't work because you have no control over the networks they are connecting from. Instead, they can use remote access VPN. It allows individual users to securely connect to a private network from a remote location using the internet. Users typically need to install a VPN client software on their devices, which facilitates the connection to the VPN server. It allows remote users to access resources on the internal network as if they were physically present in the office. I'm sure you guys have experienced this now. To establish a secure VPN connection, remote access VPNs frequently rely on the Transport Layer Protocol, Transport Layer Security Protocol, TLS. Let me show you how. A web browser, for example, let's take an example of HTTPS first. A web browser supports HTTPS, right? With TLS to dynamically create a secure connection from the web browser to a web server supporting safe online access to financial transaction. The same TLS technology can be used to create a client VPN that secures all packet from the device to the site by using Cisco VPN client. The Cisco AnyConnect Secure Mobility Client, that is AnyConnect Client for short, is software that sits on user's PC and uses TLS to create one end of VPN remote access tunnel. As a result, all the packets sent to the other end of the tunnel are encrypted. As you can see here, a VPN tunnel for PC using AnyConnect client to create a client VPN. The AnyConnect client creates a TLS tunnel to the firewall that has been installed to expect VPN clients to connect to it. Here the tunnel encrypts all the traffic so that PCA can use any application available at the enterprise network on the right. So here all the packets will be encrypted from PCA till the firewall, and the packets are safe because of that. So let's quickly compare between site-to-site VPN and access VPN. The typical security protocol used in remote access, as I said, is TLS, whereas in site-to-site it uses IPsec. And the devices supported by one VPN or many remote access will support only one, and site-to-site you can have many. And typical use, whether it's on demand or permanent, remote access is on demand. Whenever you want to connect, you have to connect it. Site to site, it's available all the time. That's it for this session. I hope this was informative for you. Thank you for watching.